If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay students, so welcome you to the lecture 1 of this quadratic equation series. So there will be 3 modules: basic, intermediate and advanced. So in the basic module I will be talking about diploma level only. And I will be discussing some question papers, previous year question papers of diploma first year Tripura University questions, that is from 2009 onwards. I will be taking questions. In the intermediate level we will be taking questions from JEE main last 10 to 15 years questions 2003 onwards, and in the advanced level we will be taking IIT JEE entrance questions or JEE advanced question from 1999 onwards. Okay, then let's start discussing about quadratic equation. So okay students, so quadratic equation, if we start quadratic equation, so if you see quadratic equation, a very standard format, this is the format. I will be sharing these notes. So this is the format: ax square plus bx plus c, very standard format. This type of expression is known as quadratic equation, provided that these conditions you always try to have an idea about what they are saying about because these are initially it may look like it is not anything, but simple concepts are built up of these expressions. So a is not equal to 0 means if a is 0, then this vanishes. So the highest power of quadratic equation is always 2, so it doesn't remains there. So that's why it cannot be equal to 0. And also ABC, so ABC, that coefficients, these are known as the coefficients of this one, so they all belongs to a real value, not x. So ABC, all this becomes a real value. ABC, they should be a real number, the coefficients, then we say it is a quadratic equation. Okay, if I say alpha is a root of the quadratic equation, root means if we solve this equation you will find some value of x, that's are known as the roots of the quadratic equation. So if alpha is a roots, that means in place of x, if you put alpha, it should satisfy. So this is my x. So if I solve it, suppose at the end I got x equal to alpha, that means if I put x equal to alpha here instead of x, then it should satisfy. So that is the name of the roots, meaning of the roots. If someone says it is a root of the equation, then how to check? You put that value in the equation. If the left and right hand satisfy, that is left hand is this side, right hand is 0, then we say it is a roots of that equation. Now if what is the two roots? Now while solving this one, this is the formula, famous Sridharacharya formula, or you can also before going through this, let me show how it came. So if I divide it by a, then it's become this. So next idea is to make it a perfect square, because if you can make it a perfect square, then a perfect square means either a plus b whole square or a minus. If you make it a perfect square, a square plus 2 into this is a, and this should be with b. What should be with b? So that it becomes b by ax. So if you give 2 to cancel, then it will remain same. So this one is converted into 2ab, you can see. So plus a square plus 2ab plus b square, because I am giving this one extra because this one is not there, that's why I have to deduct this one. So now you can see this is a plus b whole square, and then this is c by a minus b by 2a whole square equal to 0. Now you can do it. If you solve it, you will find it. If you solve it, then it is 4a square, then it is 4ac minus b square with a minus sign, or you can write it b square minus 4ac by 4a square. If you take LCM here, it will come. So your x is equal to, if you take root and then if you send this minus b by 2a, then that root is a root, square root is always, you will get 2 value plus minus. So now you can see this is coming. So this is in, if you take again LCM, so it will look like this. So this is the famous formula, Sridharacharya formula, to calculate the value of x. So these are the roots they are saying here. So one, if you take alpha, then the second one will be your beta. That is the idea. You can take any one alpha, you can take any one beta. If you take plus 1 alpha, then the minus 1 will become beta. It is not mandatory, you can take anything. Now this factor, b square minus 4ac, this one, that is under root, which is known as the discriminant. Discriminant means by seeing this value, you can predict something about x, what will be the outcome. That x means here roots. You are getting the roots. So what will be the outcome of how the nature of the roots, either it will be real, or it will be imaginary, or it will be rational, equal, unequal. So this can be said by using this, by seeing only this one. So this is known as discriminant, that is denoted by d. So d is my b square minus 4ac. You can see it here. Now if you see, if d is less than 0, then what will be your roots? Can we say something about root? If d is less than 0, that means it will under root, it will be negative value. Root minus 5, root minus 6. So as of now, you know these negative value roots are not real numbers, so these are imaginary numbers, that's why roots are imaginary. Now if d is greater than 0, suppose root 25, root 30, so that means you will get some real value, but root 30 will not be a rational number. So that's why, because we are not saying it is a perfect square or not, if it is simply positive, it can be 25, it can be 26 also. That means you will get some real value, but the values will be unequal, because one time you will be plus, you will do plus, and one time you will do minus. So it's a real and unequal if d is greater than 0. If d equal to 0, if it becomes 0, then both the roots, this side becomes 0, then both the roots will be minus b by 2a, minus b by 2a, then the roots are real and equal, we say. If d is a perfect square, it becomes a perfect square, then what will happen? If it is a perfect square, then you will get, suppose root 25, then you will get 5. So root will be already gone. So you will find rational roots, because there will be no, it will not be a surd. These roots you can easily take out. It is 36, root 36 means it will 6 will come out. So it will be rational number. Irrational will be when there is a root. Suppose root 30. Root 30 you cannot find directly square root. So it becomes irrational. So if it is a perfect square, then it becomes irrational. So these are the nature of roots. Again, a very important zone. By seeing d you can do it. Now what are the relation between the roots? If you take the sum of these two roots, if I take alpha is equal to minus b plus b square minus 4ac by 2ic, and if you take beta is equal to minus b square minus 4ac by 2ic, and then if you add these two, you will see that b square minus 4ac minus b square minus 4ac will get cancelled, and then alpha plus beta will be equal to db2b, so it will be 2 cancel minus b by a. So it becomes a formula. So you have to know from where this formula is coming before you directly memorize it. Ultimately you have to memorize it. Then you have to, if you take the product of these two, then it is a plus b into a minus b, a square minus b square. So if you do then it will be minus b square, that is b square, minus this square is b square minus 4ac, because root will be gone, a square minus b square, and then 2a will be 4a square. So if you do it, then you will find it b square cancel, it will be c by a. So again this becomes again another formula. Again you have to remember this formula, but you have to know from where it is coming. Now if you have both the roots, suppose you have alpha, you have beta, both the roots are given. Now you have to go back, you have to find the equation now. Now how the equations can be written? Now as you can see, the equations can be written of this format, because I have divided by a. So if I do it in this, again I write it ax square plus bx plus c. If I divide it by a, then it becomes x square plus b by a plus c by a equal to 0. Then in place of b by a, if I put this value, the x square minus, it will be alpha plus beta x. In place of c by a, if I put, so this becomes again a formula. If alpha beta is given, now I can, if equation is given, you can find alpha beta using these formulas. These alpha and betas, x means your roots, that is alpha and beta, you can calculate using this. Now reverse, if alpha beta is given, then you can form the equation using this. So both way you can go. Now next two important theorems, that is if alpha plus beta I is a root, I means imaginary number. Imaginary number, if you do complex number, you will get to know. That is root minus 9 is also, you can calculate, that is root minus 1 is I, so it will be 3i. So if it is a root, then the conjugate, that is conjugate is the alpha plus I beta, is conjugate is alpha minus I beta, if you take the negative sign of imaginary part, will also be a root. Now if you see here, because it is plus minus, so if one comes 3i, then square root, another one will be minus. So obviously if one comes alpha plus I beta, this is alpha, then it is I beta, I will come from this because it is negative, then it will give imaginary. So another one will be minus obviously, but this condition you have to remember, this one. For this, your ABC all should be real values. It should not be like that ABC are not real values, then you are good. If ABC, these coefficients are different, these coefficients are not real values, then this theorem doesn't hold. You have to be careful about that. If alpha plus root beta, that is a surd, is a root, then alpha minus root beta. It is irrational, again it is suppose root 30. So one will be plus root 30, one will be minus root 30. So one will be plus root beta, one will be minus root beta. So these are known as conjugate surds, provided that beta is not a perfect square. And again you have to remember, because beta becomes perfect square, then it doesn't hold, then both will be alpha alpha, then there is no question of plus and minus. Then it will be, something will come from, if it is a perfect square, something will come from this, then one will be alpha minus that, one will be, the roots will not be there, it will not be a surd. So if not is a surd, then conjugate will not come. That's why it should not be perfect square for this theorem, because this is conjugate surd. And ABC should be rational. This one also you have to be very careful. This ABC should be, if A, B, C anywhere is, it is root 2 suppose, 2a plus 2a square plus 3a, 2x square plus 3x plus root 2. In that case this theorem will not hold, because your C is not a rational value. So this you have to be careful here. For this theorem to hold, this should be real number. For conjugate surd to happen, this should be rational. All ABC should be rational. So these are all about your theories that are basics, writing basics. So these are basic theories. If you like the video, then press the like button and please give your valuable comments in the comment section.